This video we will discuss about basic electrical engineering, important questions and answers, part 3 of AC circuits. A coil has a resistance of 20 ohms and inductance of 80 millihenries and is connected in series with 100 picofarad capacitor. If the supply voltage of 230 volts 50 Hz is applied to the ends of the circuit, determine the circuit impedance and current. Now in the given question, given data is resistance is given which is 20 ohms, inductance is 80 millihenries which is nothing but 80 into 10 power minus 3 henries. Milli means 10 power minus 3. Whereas capacitor C is 100 picofarad. Pico means 10 power minus 12 which is equals to 100 into 10 power minus 12 farads. Voltage V equals to 230 volts and F is frequency is 50 Hz. The formulas used are omega is equals to 2 pi f. Omega is nothing but angular frequency is 2 pi f. Capacitive reactance Xc is equals to 1 by omega c and inductive reactance XL equals to 1 omega L and impedance Z equals to R plus J XL minus XC and current I is given by I equals to V by Z. Substituting the frequency F equals to 50 Hz, then 2 pi into 50 equals to 314.15. Units for omega is radians per second. Xc is equals to 1 by omega c is equals to 1 by 314.15 into 100 into 10 power minus 12 which is given by 31.83 into 10 power 6 ohms. XL is omega L 314.15 into 0.08 which is equals to 25.13 ohms. The formula for impedance Z equals to R plus J XL minus XC which is equals to 20 plus J 25.13 minus 31.83 into 10 power 6 which is equals to 20 minus J 31.83 into 10 power 6. Now you can obtain the magnitude is 31.83 into 10 power 6 at an angle of minus 89.99 ohms. Current I equals to V by Z. By substituting the formula, voltage is given is 230. The value of impedance you are obtained is 31.83 into 10 power 6 at an angle of minus 89.99. Then you can obtain the value of current I is equals to 7.23 into 10 power minus 6 at an angle of 89.99 which is equals to 7.23 microamperes. Here the angle is positive, then current is leading. A resistance of 15 ohms and a capacitance of 100 microfarad are connected in series across a 50 volts RMS 50 Hz supply. Find current, phase angle, voltage across each element, active and reactive power. Given data is resistor is given R equals to 15 ohms, capacitance is given C is equals to 100 microfarads and voltage is given which is 50 volts and frequency is 50 Hz. Now the formulas used omega equals to 2 pi f and xc is equals to 1 by omega c and z equals to r minus jxc and current formula is I equals to V by Z and voltage across each element, voltage across resistor VR equals to I into R, whereas voltage across capacitor is VC equals to I into XC and the formula for active power is VI cos phi and the formula for reactive power is VI sin phi. Now by substituting the value omega equals to 2 pi f 2 pi into 50 which is equals to 314.15 radians per second. Xc is 1 by omega c. By substituting the value of omega is 314.15 and the value of capacitance is 100 microfarads, you can obtain the value of Xc is 31.83. The value of impedance Z equals to R minus jXc which is equals to 15 minus J 31.83. which is equals to 35.18 at an angle of minus 64.76. Current I equals to V by Z. Therefore, 50 by 35.18 at an angle of minus 64.76, which is equals to 1.42 at an angle of 64.76 amperes. Voltage across each element VR is equals to IR is equals to 1.42 is the magnitude multiplied by 15 ohms is the value of resistance, which is equals to 21.31 volts. Voltage across the capacitor I into X is 1.42 multiplied by 31.83, which is equals to 45.22 volts. Active power is VI cos phi. Voltage is 50 and the value of current is 1.42. Cos of angle is 64.76, which is equals to 30.28 watts. Reactive power is VA sin phi equals to 50 into 1.42 into sin 64.76 equals to 64.27 VAR, volt ampere reactive. Units for reactive power is VAR. Derive an expression for average power in a single phase circuit contains pure capacitor across sinusoidal voltage. Consider a circuit consisting of a single capacitor C excited by a sinusoidal alternating voltage V equals to Vm sin omega t. The circuit is as shown in figure. For the circuit shown in figure, I is equals to C dV by dt. By substituting the V equals to Vm sin omega t, I equals to C into d by dt of Vm sin omega t. You can take Vm as common, therefore I equals to C Vm d by dt of sin omega t. Now we can take common Vm, therefore I is equals to C Vm d by dt of sin omega t. Therefore I is equals to C into Vm into omega cos omega t. Now we can write cos omega t as sin 90 plus omega t. Therefore I is equals to Vm by Xc sin 90 plus omega t. From the equation, phasor diagram will be this is now where V is the reference, I is the current sin 90 plus omega t. That's why we are representing in a positive y-axis, where V is the supply voltage and I is the current. By taking voltage as a reference, current through the capacitor I leads the voltage by an angle of 90 degrees. The expression for power P is given by P is equals to VI. Power P is equals to VI, Vm sin omega t into Im sin omega t plus 90. We can write Vm into Im sin omega t into sin omega t plus 90. Therefore, power P is equals to multiply with 2 and divide with 2. We can write Im into Vm by 2 sin omega t plus 90. This is in terms of sin A, sin B. You can write sin A, 2 sin A sin B as cos A minus B minus of cos A plus B. Therefore, power P is equals to Vm into Im by 2 cos 90 minus Vm into Im by 2 cos 2 omega t plus 90. Since the value of cos 90 is 0, power P is equals to 0 minus Vm into Im by 2 cos 2 omega t plus 90. Since the average value of cos 2 omega t over a half cycle is 0, then the value of power P is equals to 0. Thank you for watching. Please like, share and subscribe if you like.